Today we're going to be studying mathematics
and emerges from the second mirror.
These words sound
Be your teacher for today.
Hello everyone, how are you doing today? I hope you didn't find the previous home fun exercises difficult. In the previous lessons, we've learned whole numbers, counting in thousands, millions and billions. We also learned lowest common multiples and highest common factor, HCF. We'll be needing those knowledge in subsequent lessons, so you need to keep them at the back of your mind. Today we'll be talking about fractions. Fraction means a part of a whole, a part of a whole. For instance, I have this, a whole. This is one whole, a whole. Now, a fraction is a part of a whole. This one whole can be made into parts. For instance, I can cut this into two parts. This is into two parts, half and another half. Half plus half will give me one whole. Now, this is another one whole. I could cut into as many parts as I want. For instance, I could cut this now. I have four equal parts. Four equal parts. This would be a quarter plus another quarter, giving me half. A quarter plus another quarter, giving me half. A quarter, another quarter, plus another quarter, giving me 3/4. 3/4. 3/4. Now, if I have the four portions back together, 2 quarters making half, another 2 quarters making half, joined together, I have one whole back. Now, for instance, I have this. The shaded portion, I had a whole object, a circle, which I divided into 4 parts. I shaded 1 part out of 4 parts. So the shaded portion is 1 out of 4. 1 out of 4. I have shaded 1 out of 1, 2, 3, 4. 1 out of 4. Now I have another shape. Now let's do the unshaded portion. Unshaded portion. The unshaded portion. I have this object, a whole, divided into 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, unshaded portion. Unshaded parts. 1, 2, 3, 4, 5. The unshaded portion is 5 out of 8. I call this upper number, the number on top, a numerator. Numerator, and the lower number, denominator. We have 3 types of fraction. Types of fractions. Types of fractions. 1, we have proper fraction. Proper fraction. In a proper fraction, the numerator is lower than the denominator. It's like a father carrying the child. For instance, 5/8. The denominator is higher than the numerator. The numerator is less than the denominator. So this is a proper fraction. Another example of a proper fraction could be 1/3, 7/9, and so on. Another type of fraction is improper fraction. Improper fraction. Imagine a little boy, 5-year-old boy, carrying the father. That is improper fraction. For instance, we have 8/5. 5-year-old boy carrying the father. Improper fraction. Another example of an improper fraction could be 7/5, and so on. Improper fraction. Another type of fraction we have is the mixed fraction. Mixed fraction. I said we're going to be applying the knowledge of what we have learned in the previous lessons in this lesson. We've learned whole numbers, and in mixed fraction we have a whole number together with a proper fraction. A whole number together with a proper fraction. It is mixed fraction. Mixed fraction. For instance, 3 whole number 2/5. Whole number, 3 whole number 2/5. The 3 is a whole number. The 2/5 is a proper fraction. Another example, we could have 7 whole number 9/10. 7 whole number 9/10. 9/10 is a proper fraction. 7 is a whole number. Now we could change from one fraction to another fraction. For instance, this improper fraction could be changed to a mixed fraction. We could change improper fraction to a mixed fraction. For instance, 7/4. 7/4 is an improper fraction. We could change this to a mixed fraction. How many 4 can I get from 7? How many 4 can I get from 7? I could get 1 4. That will give me one whole number. Then 7 minus 4 is 3. I have one whole number remaining 3. I now have 3 all over 4. So 7 all over 4 becomes one whole number 3/4. I could also change a mixed fraction to an improper fraction. A mixed fraction could be changed to an improper fraction. In this example, I had 3 whole number 2/5. I could change 3 whole number 2/5 to an improper fraction. What do? This is 3 whole number. What I do is 3 times the denominator. I'll do this. 3 times 5 plus 2 all over 5. 3 times 5 plus 2 all over 5. 3 times 5 is 15. This gives me 15 plus 2 over 5. 15 plus 2 is 17 over 5. So 17 over 5 would be an improper fraction. Remember, a little child carrying the father. Improper fraction. Now, let's move on to ordering fractions. Ordering fractions. We want to order fractions. We want to arrange fractions. We could use terms like greater than, less than, or equal to. Greater than, less than, or equal to. This is the greater than sign, your right hand, greater than, less than, your left hand, and equal to. Now, move to other fraction. We want to know which fraction is bigger and which is smaller. Here comes the application of LCM. For instance, we want to order this number 4 over 5, 5 over 6. The question is 4 over 5 greater than, less than, or equal to 5 over 6? How do we do this? Look at the denominators. The denominators are not the same. For us to be able to compare, the denominators have to be the same. So what do? We look for the LCM of 5 and 6. LCM of 5 and 6. Let's do it this way. LCM of 5 and 6. What number could divide? Let's use 2. 2 cannot go in 5, so we write our 5 back. 2 can divide 6 3 times. What number could go again? 3. 3 cannot divide 5, we write 5 back. 3, how many 3 can we find in 3? 1. This is settled. We have 1 already. Now what will we use to divide 5? 5 is a prime number, so the only number that could divide 5 is 5. So the LCM of 5 and 6, LCM of 5 and 6 will be 2 times 3 times 5. 2 times 3 is 6, times 5 is 30. So the LCM of 5 and 6 is 30. That means the denominator we'll be able to use that will give us a parameter for comparison would be 30. So we need to change these numbers to have same denominators. So we have over 30 here, over 30. Now, how many 5 can we find in 30? How many 5 can we find in 30? 6. 6 times 4. 30 divided by 5, 6. Then 6 times 4 will give us 24. 24. How many 6 can we find in 30? How many 6 can we find in 30? 5. 5 times 5 is 25. What I have just done is an equivalent fraction because 24 over 30 is the same thing as 4 over 5. And 25 over 30 is the same thing as 5 over 6. Equivalent fraction. So I now have a basis for comparison. I have a basis for comparison. Unlike in the original question, I didn't have a basis for comparison. So I have 24 over 30 and I have 25 over 30. Now the question is 24 over 30 greater than, less than, or equal to 25 over 30? Correct? The answer would be less than. 24 is less than 25. So I come in here. 24 over 30 is less than 25 over 30. But this is not the original question I was given, so I have to change back to the original question. The original question will be 4 over 5 is less than 5 over 6. 4 over 5 is less than 5 over 6. I didn't just get that answer, we worked it out together. Let's take another example. 3 over 4, 2 over 3. Is 3 over 4 greater than, less than, or equal to 2 over 3? Let's do this together. We find the LCM of 4 and 3. LCM of 4 and 3. What could divide these two? How many 2 can we find in 4? 2, 3. What could divide 2, 1, 3? What would we use now? 3, 1, 1. So the LCM of 4 and 3 is 2 times 2 times 3. 2 times 2, 4 times 3, 12. So the LCM of 4 and 3 is 12. So we need to change the denominator into 12. So we have over 12 over 12. How many 4 can we find in 12? 3. 3 times 3, 9. Now, how many 3 can we find in 12? 12 divided by 3 will give us 4. 4 times 2 is 8. We have a basis for comparison. 9 over 12, 8 over 12. Which is greater? This. For that reason, 9 over 12 will be greater than 8 over 12. 9 over 12 will be greater than 8 over 12. We come back to our original question. 3 over 4, 2 over 3. So we can now say 3 over 4 is greater than 2 over 3. Let's take another example. We have 4 over 9 and then 12 over 27. 4 over 9, 12 over 27. So we want to know, is 4 over 9 greater than, less than, or equal to 12 over 27? What is the first thing to do? The denominators are not the same. So we need to find the same denominators. What is the LCM? Lowest common multiple of 9 and 27. 9, 27. What could divide? Let's use 3. How many 3 can we find in 9? 3. How many 3 can we find in 27? 9. 3 could go again. 1, 3. 3 could go again. 1 here, 1 here. So the LCM of 9 and 27 will be 3 times 3 times 3. 3 times 3, 9. And 9 times 3, 27. So the LCM of 9 and 27 is 27. LCM of 9 and 27 is LCM of 9 and 27 is 27. So we come here, change the denominators. How many 9 can I find in 27? How many 9 can I find in 27? 3. 27 divided by 9 will give me 3. Then 3 times 4 would be 12. I have 12 over 27. How many 27 can I find in 27? 1. 1 times 12 is 12. Now, I have 12 over 27. 12 over 27, they are the same. So I say 12 over 27 is equal to 12 over 27. Remember, that is not the original question. So I have to change back to the original question. 4 over 9 is equal to 12 over 27. I hope you got that. Now, still ordering fractions, we are going to be arranging fractions in descending order. When we were learning decimal numbers, we arrange the numbers in ascending order, ascending from the lowest to the highest. But now we want to descending order from the highest to the lowest. For example, we want 5 over 6, 5 over 8, 2 over 3, and 3 over 4. We want to arrange these fractions in descending order. LCM comes to play. The denominators are not the same. So we need to have a common denominator. We need to have a common denominator. What do? Look for the LCM of 6, 8, 3, and 4. LCM of 6, 8, 3, and 4. 6, 8, 3, and 4. What number could we use to divide? The lowest number, 2. How many 2 can I find on 6? 3. How many 2 can I find in 8? 4. How many 2 can I find in 3 without a remainder? None. So, I'll write my 3 back. How many 2 can I find in 4? 2. What number could I use to divide again? 2. How many 2 can I find in 3? Without a remainder, none. So I'll write my 3 back. How many 2 can I find in 4? 2. How many 2 can I find in 3 without a remainder? None. So I'll write my 3. How many 2 can I find in 2? 1. What number can I use to divide again? 2. 3. How many 2 in 2? 1. 3. 1. Now, I use 3 to divide. How many 3 can I find in 3? 1. 1. 1. 1. So I'm 2. Now, the LCM of 6, 8, 3, and 4 would be 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. Which means the LCM of 6, 8, 3, and 4 is 24. How many 6 can I find in 24? 4. 6 times 4 is 24. Now, 4 times 5, 20. So, 5 over 6 is equivalent to 20 over 24. Now, how many 8s can I find in 24? 3. 3 times 5 is 15. Meaning, 15 over 24 is equivalent to 5 over 8. How many 3 can I find in 24? 8. 8 times 2, 16. How many 4 can I find in 24? 6. 6 times 3, 18. What have I done? Equivalent fraction. I have just changed this fraction to the equivalent fraction. So, what do I need to do? Compare. I can now compare. Now, remember, I'm arranging in descending order. Let's do this. Descending order. That means from the highest to the lowest. Looking at this, what number is the highest? 20 over 24 is the highest. So 20 over 24 comes first, followed by 18 over 24, then 16 over 24, lastly 15 over 24. I have arranged these numbers in descending order, but remember, this was not the original form of the question, so I need to change it back to the original question. 20 over 24 is 5 over 6, so in descending order, 5 over 6. 18 over 24 is 3 over 4. I have 3 over 4. 16 over 24 is 2 over 3. 2 over 3. Then 15 over 24 is 5 over 8. 5 over 8. We have been able to arrange these numbers in descending order. Fractions in descending order. 1 over 3, 4 over 9, 5 over 8, 3 over 4, and 1 over 6. 1 over 3, 4 over 9, 5 over 8, 3 over 4, and 1 over 6. We want to arrange these numbers in descending order. What do? The denominators are not the same, so we look for the LCM. LCM of 3, 9, 8, 4, and 6. 3, 9, 8, 4, and 6. What number could we use to divide? Let's try 2. 2 wouldn't go in 3 without a remainder, so 3, 9, 4, 2 in 4, 2, 2 in 6, 3. What could we use again? 2, 3, 9, 2, 1, 3. What could we use again? Smallest number, 2, 2 and 3, still 3, 9, 1, 1, 3. What could we use now? 3, 1, 3, 1, 1, 1. We still have 3, 1, 1, 1, 1, 1. So the LCM is 2 times 2 times 2 times 3 times 3. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. And 24 times 3, 72. So the LCM of 3, 9, 8, 4, and 6 is 72. So the denominator will now be 72. So we have to come back and change all of this to 72. Okay, how many 3 can I find in 72? How many 3 can I find in 72? How many 3 can I find in 7? 2, remain the 1, 4. So I have 24. 24 times 1 is 24. How many 9 can I find in 72? How many 9 can I find in 72? That would be 8. 9 times 8 should give us 72. So 8 times 4, 8 times 4, 32. How many 8s can I find in 72? Is 9. Then 9 times 5 would give us 45. How many 4 can I find in 72? How many 4 can I find in 72? 1, remainder 3, that's 8. So 18. Now 18 times 3. 18 times 3. 3 times 8, 24. 3 times 1, 2, that's 54. 3 times 1, 3, plus 2, 5, that's 54. How many 6 can I find in 72? 12. Now 12 times 1 is 12. I've succeeded in having the same denominators. The next step is to arrange in descending order from the highest to the lowest. What number is highest here? 24 over 72, 32 over 72, 45 over 72, 54 over 72, and 12 over 72. Sure, 54 over 72. So the highest, 54 over 72, followed by 45 over 72. Next is 32 over 72. Next is 24 over 72. And lastly, 12 over 72. Many students make mistake by stopping here. This is not the form of the original question. So we need to change back to the original question. 54 over 72. 54 over 72 is 3 over 4. So 3 over 4 comes first. 45 over 72. 45 over 72 is 5 over 8. 5 over 8. 32 over 72. 32 over 72 is 4 over 9. 24 over 72 is 1 over 3. And lastly, 12 over 72 is 1 over 6. I'm sure you got that. So we've been able to arrange these numbers in descending order. You could also arrange in ascending order from the highest to the lowest, which is just same method. The only difference comes in here, where you have to start from the lowest to the highest to go in the ascending order. Now we are going to be learning to add up fractions. Please, addition of fractions. Three over 4 plus 5 over 7. We want to add up these fractions. Look at those numbers. The denominators are not the same. We could have some fractions where the denominators are the same. We just go ahead and add directly. But those denominators are not the same. So we need to work on these denominators to have the same denominator, to have a basis for addition. What is the LCM of 4 and 7? LCM of 4 and 7. 4 and 7. 2 will divide 4. 2 will not divide 7 without a remainder. So we write our 7 back. How many 2 can we find in 2? 1. 2 will not divide it without a remainder. We have 7. What else do we have here? 7. 7 here, 1. 1. So the LCM is 2 times 2 times 7. 2 times 2 is 4. And 4 times 7 is 28. So the LCM of 4 and 7 is 28. We change to the same denominators. Over 28. Over 28. How many 4 can I find in 28? 7. 7 times 3. 7 times 3 is 21. Meaning 21 over 28 is an equivalent fraction to 3 over 4. How many 7 can I find in 28? 4. 4 times 5, 20. Now they have both the same denominators. We want to add up. I could do this way. 21 plus 20. 21 plus 20 will give me 41 over 28. 41 over 28. Can you recall what type of fraction is this? An improper fraction. The denominator is lower than the numerator. So what do? We need to change this to a mixed fraction. 41 over 28. Changing it to a mixed fraction. How many 28s can I find in 41? 1. 41 minus 28. 11 minus 8. 3. 3 minus 2. 1. So I have one whole number. That means I can find a complete 28, set of 28, one complete set of 28 in 41, one whole number, 13 over 28. So this would be our final answer. Okay, I have this 5 whole number 1 over 4 plus 1 whole number 3 over 8. I want to add up these fractions. I could use two methods. The first method is to add up the whole numbers first, then add up the fractions and sum them up. This way, 5 whole number plus 1 whole number, 5 plus 1, which is the whole number, plus 1 over 4 plus 3 over 8. What have I done? I had 5 whole number 1 over 4 plus 1 whole number 3 over 8. I had taken the whole number first, then taken the fractions separately. 5 plus 1 is 6. So 6 plus. Now I deal with the fractions. 1 over 4 plus 3 over 8. 1 over 4 plus 3 over 8. The denominators are not the same. We need to find the LCM of 4 and 8. The LCM of 4 and 8 is 8. How many 4 can I get in 8? 2. 2 times 1, 2. Implying that 1 over 4 is equivalent to 2 over 8. Now, they are the same. The denominator here is still the denominator here. So I could just come over and write the 3 here, but 8, how many 8 can I get in 8? 1. 1 times 3, 3. So, having done this, I have 6 plus 2 plus 3. Because the LCM, the denominator is now the same, I could add directly. So I have 6 plus 2 plus 3, 5 over 8, giving me 6 whole number 5 over 8. Now method 2. This is one method. Method 2. I have 5 whole number 1 over 4 plus 1 whole number 3 over 8. What do? This is a mixed fraction. I convert to an improper fraction. 5. How do I do this? 5 times 4 plus 1 all over 4 plus 8 times 1 plus 3 all over 8. This gives me 5 times 4, 20, plus 1, 21. So I have 21 over 4. That means 5 whole number 1 over 4 is same as 21 over 4, plus 8 times 1, 8, plus 3, 11. 11 over 8. I have 21 over 4 plus 11 over 8. The denominators are not the same. I have to change the denominator to be the same. The LCM of 4 and 8, like we did in the other method, is 8. So I go directly. What I have now is 21 over 4 plus 11 over 8. The LCM is 8. So how many 4 can I get in 8? 2. 2 times 21 is 42. 42 plus, how many 8 can I get in 8? 1. 1 times 11 is 11. So I have 42 plus 11. 42 plus 11 all over 8. 42 plus 11 is 53. 53 over 8. I want to change 53 over 8 is an improper fraction. 53 over 8. How many 8 can I find in 53? 6. 8 times 6 is 48. So I have 6 whole number. 8 times 6 is 48. So 53 minus 48. 13 minus 8 is 5. So I can get a complete set, 6 complete sets of 8s from 53. That's 6 whole number. Remainder 5. So 5 over 8. This is our answer, and you can see same here. So whichever method you choose to use, you should arrive at the same answer. I believe we've been able to understand this subtraction of fractions. Examples. We have okay, 7 whole number 2 over 3 minus 3 whole number 5 over 6. Just like we did in the last question, we could use 2 methods. We could subtract the whole numbers first, then the fractions. Otherwise, we could change the mixed fraction to an improper fraction and do the subtraction directly. Now, let's do this together. Let's change this to a mixed fraction. 7 times 3 plus 2 all over 3 minus 6 times 3 plus 5 over 6. 7 times 3 is 21. 21 plus 2 is 23. So I have 23 over 3 minus 6 times 3 is 18. 18 plus 5 is 23. I have 23 over 6. Wow. 23 over 3, 23 over 6. If you're not careful, you just think the answer is 0 because you have 23 here and 23 here. But look at the denominators, they are not the same. So we need to have the same denominator. We need to find the LCM of 3 and 6. What is the LCM of 3 and 6? The LCM of 3 and 6 should be 6. So LCM of 3 and 6 is 6. So we change this over 6 minus over 6. How many 6 can we, how many 3 can I find in 6? 2. 6 divided by 3 is 2. 2 times 23 would give me 46. 46. Then how many 6 can I find in 6? 1. 1 times 23 would give me 23. So I have 46 over 6 equivalent to 23 over 3, equivalent to 7 whole number 2 over 3, and I have 23 over 6 equivalent to 3 whole number 5 over 6. Now I have the basics, both denominators are the same, so I could just do this: 46 minus 23 all over 6. 43 minus 23 should give me 23. 46 minus 23, 6 minus 3, 3, 4 minus 2, 2. So this is 23 over 6. So 23 over 3 minus 23 over 6, giving me 23 over 6. Improper fraction. I need to change it back to a mixed fraction. 23 over 6 would give me, how many 6 can I find in 23? That's 3. 6 times 3 is 18. So 3 whole number, 23 minus 18. 13 minus 8 here is 5. So I have 3 whole number remainder 5. 5 over 6. 3 whole number 5 over 6. So this is our final answer. I hope that is clear. We started by showing the fraction is a part of a whole. We changed fractions. We ordered fractions using greater than, less than, equal to. We also arranged fractions in descending order. We could also arrange in ascending order. We went ahead to add fractions, to subtract fractions. We could also change fractions from one form to another. So let's do this together. You have this as home fun.
Let's add up. Then let's subtract. Now, you also find out, you change fractions into decimals. Change. Okay?
I'm sure going through what we've already done, you should be able to do this. Remember, we're going to write an exam at the end of this module. We've been able to go through 3 topics already, and we have 4 more topics left. At the end of the topics, you should be able to attend the examination. I hope you enjoyed the lesson. Meet you in the next class. Thank you.